In this chapter, we will learn how to patch the APK and to bypass the application debugger check. So first, let's open the APK for debugging. We can see the Java code in the left panel, the Java classes, but currently they are represented as a smiley code. Let's open the emulator and launch the application in a debug mode. So we have two fields which check for debugging. The first one, look for a field in the manifest file. As you see here, we have the Android debugger set to true. This is why we see the application say that it's true. The second one is debugger present set to true. It's based on an API which go and check if the debugger is currently connected to the application. So let's stop the application and we will run the application again, but not in a debug mode, in a regular mode. Let's check the result. We see that the first field is still true, which is true. The second one is false because we are currently running without a debugger attached. The next step is to open the APK using JDEX in order to analyze the APK and to understand the application code, so we can find the exactly code that's responsible for the checks. We can patch the application and do whatever we need to do in order to bypass the debugger check. In this Android manifest file, we look for the first activity that is happening, which is login log activity class. Inside this class, we will see the onCreate. As we learned before, onCreate is the first event that will happen when the activity is launched. So this will be the first activity that will run. Finding this class and the code, we can now press Ctrl+F and to look for click. We look for click because while we pressing the click button, then the things is happening and the check is occur. So as we see, we found the onClick listener. Inside we see the onClick method. This method responsible for the code that will be launched while we press the check button. Inside the onClick function, we see the df and dp setText function call. This function used in order to update the text field, which in our application represent the is debugger attached, is the application with the debug flag or without. And inside we see that it updates the field with F and P. F and P are Boolean values, and they get the values by calling to the login result class and calling to the xx12f and xx13p functions, which are a part of the login result class. So we now go to the login result class and let's analyze the functions. So the first functions call to isDef function. We go to the isDef and we see that it uses some system called API. We check is debugger flagged or not. So it's kind of check the Android manifest file in order to see that the flag is existed or not. The second one is xx13p. This function called to isDP, isDebugger present, and here it's called to some system API which called to isDebugger connected, which is a kind of a lower system API to check if the debugger is currently attached to the application. After we understand that, we can try to manipulate the application and to patch the code in order to bypass the debug check. We will do it by modifying the Smiley code. Let's see the Smiley code. We press the Smiley button and we see the same code but in Smiley. And let's look for the same functions that are responsible for the checking the debug flag and is debugger present. And what we need to do is instead returning true, we need to return false. So false returned by returning a 0 with the function returned. To perform the actual patch, we will open APK Studio in order to modify the Smiley code and then to make the patch. So let's open first APK Studio. Let's set first the view so it will be more comfortable to see the console and the APK files. Second, we open the APK. We will choose to decompile the Java code. APK decompile the Java files, and finally we got the result. So inside the Smiley folder we see all the Java decompiles files. What we need to do is to go to the same place where we found the isDP and isDF functions and to modify the returned value into false. So here we found the login result class. Pressing Ctrl+F, we can look for the specific function, but here it is, isDF. By Smiley, what we do is that we set into V00 decimal, and then the function return V0. So currently it's return false. We do the same for isDP. We finish the modification. We can now press Ctrl+S to save the result, or to choose Save by the File menu. After the modification, we go to the Project tab. We press on Build. and APK Studio rebuild the application into a new APK file. We get a return 0, which means that everything is okay, and we see in the dist folder the new APK. We now need to sign the APK, otherwise Android emulator won't give you to install the application. All the settings should be already set as configured in the installation part. You can make sure by pressing on settings, signing that the key store and key password, alias and so on are configured well. In addition, you need to make sure in the binary settings that it all set well. Make sure that app2t is configured. Just to remind you that this flag is set by using the system registry using the regid MSC tool. After it's signed, you can verify it by viewing the console. The APK is signed, and you can now install the application. You press right click on the APK and install. The second option is doing it by using the ADB, using terminal and ADB, and install the application. The third option is to simply drag in the APK into the emulator. But in this option, we will finally choose to open the APK using the Android Studio and then pressing the debug button. So let's do it. You go to the dist folder, pressing OK, opening the application for debug. Make sure that you still see the Android debuggable set to true. Launching the application with debug button. And verifying that the patch is successfully done. So indeed, in spite of the debug flag and that we are in a debug mode, the application returned false, which means that the bypass and the patch successfully done. In case we want to verify it, we can go to the right class and to see the patch that we done.